All right, in this example, we're going to look at a point in polar coordinates and then come up with a few other representations of that same polar point. So the polar point we're looking at is 5, 2/3 pi. That means that we will be 5 units from the origin here. So radially, we will be out 5 units. And we would like to be at an angle of 2 pi over 3. So 2 pi over 3 is right here on the unit circle, and we want to go out 5 units. So we'll assume that's about 5 units. And this will be our point P then. So the angle 2 pi over 3 is right there. And the next part is to come up with a positive radial value. Well, that positive radial value is 5. But we want theta to be negative. We want to be between negative 2 pi and 0, so we want to rotate clockwise instead of counterclockwise. So we're going to rotate this amount. So the representation will still have a 5 for the radial distance, but the angle will be minus 1 pi over 3, minus 2 pi over 3, minus 3 pi over 3, minus 4 pi over 3. So that will give us our second representation. The third representation, we want a negative r value. So that means that we're imagining our radial line coming out this way. And we still want to be 5 units from the origin. So the distance along here is still 5. But we want to end up over at point P on the other side. So that means that we are going to have a negative 5. So positive 5 would pull us out to here. Negative 5 is going to drop us right back onto point P. So we are going to choose a negative radial value. But then we need the angle that drops us down to here. And they want it to be between 0 and 2 pi. So we're going to come around the circle this way, all the way to that terminal ray. And that's 1, 2, 3, 4, 5 pi over 3. So that will be our representation of point P with these conditions. Now we want a positive radial value, so that's going to be 5. And the angle between 2 pi and 4 pi. So we need to rotate a full extra revolution all the way around. Let's see, let's use a different color. So our 2 pi over 3 is right there. And then we want to keep on rotating all the way back around to there again. So we want our 2 pi over 3, but we need to add 2 pi to that. So we're going to add 4 pi over 2. And that will give us 6 pi. Whoop, no it won't. We need to get a common denominator. And so this is a terrible representation of 2 pi. We want a representation of 2 pi that has a 3 in the denominator. So there is a better representation of 3 pi. Oh my gosh, a better representation of 2 pi. So 8 pi over 3. That will be our angle between 2 pi and 4 pi. All right, I hope that helps with the understanding of how you can use different representations for the same point in polar coordinates. So the representation in polar coordinates is not unique.